Crack me up. All right, here we go. Section 1.2, opener. You guys are supposed to plug this in your table. And what happened when you plugged in negative 0.1? Because that should have been about what you plugged in from below to start. 952? How about 0.01? Negative 0.01. 56? How about negative 0.001? Ooh. Did you go up to the 3 and see what the other decimals were because it just rounded it? 2.999. Okay. How about 0.1? 0.01? 05? 5? Okay. We always do 3 decimal places, kiddos. How about 0.01? 9 and 6? Okay. 0.001? Okay. Why am I not just rounding it to technically not 3 yet, right? What happened when you plugged in 0? Did anybody actually do that? Error. Right. But remember, do we really care what's going on at 0? No. What we care about is the approach. Therefore, we are able to have a hole. You put it on the side table. Thanks, Nick. What we care about is the approach. And are both sides agreeing on what y values they're approaching as you plug in these x's going to 0? Definitely. And the limit answer is... Where else do you see a 3? Right there. I wonder if that's a pattern. All right, let's get into our notes. Yesterday, we ended here, and half the class would have gotten it wrong. Ugh. Why did the limit exist? Right. It doesn't matter what's actually happening there. The hole itself, what matters is what the y values are approaching from either side. And what height were the y values approaching from either side as x's approached 1? 2. Hence why the limit is 2. Can anyone explain to me why from time to time I'm going to talk about 2 guys going to a diner? Can anyone explain to me why with limits, or how with limits, I'm going to talk about 2 guys meeting at a diner, meeting for breakfast? All right, Patricia, take it. Good. Good. If you put a little car on this side, a little car on that side, if the videos had worked this summer, you would literally see an illustration of this. A little car on this side, little car on that side. And as they're coming, meeting for breakfast, trying to meet for breakfast, that's their intention. Where they're intending to go, where they're intending to eat, doesn't matter if it's open or closed. We were talking last year about, oh, it's probably some small little family business, and every now and then it randomly closes because they're like, oh, family event, we can't be here today. So whether it's open or closed, whether they actually get into the door, sit down and eat their breakfast or not is irrelevant. The question is, are they headed to the same place? Are they meeting at the same location? Whether or not it's open or closed is inconsequential. So, are they going to the same location? Definitely. And the location is, look at the y's, look at the heights. 2. So with that, let's talk about when the limits do not exist. Let me let you guys set that up. You're not going to need to skip any other lines besides what's already there. This is literally a copy of what you saw last year. But we do have some new examples coming. Everybody is here, and you were all on time. Go team. That's a good way to start a Friday. We saw this when you thought it didn't exist. Talk about when limits do not exist. Three different cases. One of them is a technicality that we will basically ignore. One of them is a technicality you can basically ignore. But the other two, there's no ignoring it. The limit will not exist. Letter A is the most basic one, and the most important one, to be honest. Letter A is the most basic one, and yet the most important one. A is talking about, or is explaining, illustrating, oh dear, it was working well last night. A piecewise function, almost always. Sometimes when you have absolute values, or square roots of quadratics, this can happen again. But ironically, those are actually piecewise functions also, just with shortcut notation. But if you were to have a piecewise function for x less than or equal to a, and another piece for x greater than a, it could have more than one piece, or I should say more than two pieces. It could have lots of pieces, but the long story short of it is the guy who's coming from below a, you can think from west of a, and the guy who's coming from east of a, talking about that whole diner example, are they headed to the same location? So what does the limit do? Not exist. They're not even intending to meet. I mean, that's their intention in our example. However, as far as where they're actually headed and whether it's the same, the answer is no, definitely not. The limit does not. Does anybody remember how I illustrated this yesterday, oh dear, last year when we were talking about the two guys and going to the diner? How did I illustrate a piecewise function and how you can think of it? Right. One of them checked up on Yelp and saw whether the current location was still the current location or current location. Found the new location, and the other guy went to the old location. That's one way of thinking about it. So this guy is going to the old location, and then he gets there, and it's like, oh, it closed and moved? Bummer. He's not getting breakfast there, right? He's going to have to somehow redirect. But this guy, well, he checked it out beforehand, or he already knew about the new location. Breakfast is being served there, not there. But yeah, that's one idea of thinking about it. One guy heads to the old location, one guy heads to the new location. They're headed, intending to head to the same place, just they're not meeting. They're not meeting. So we would call this function not continuous. We would also say the limit does not exist. Okay, letter B. Letter B is the technicality. Letter B is the technicality. Now, letter B is dealing with a vertical asymptote. As we come towards A, the diner example doesn't quite work on this one. However, as we come towards A, what if there's a vertical asymptote? What are the different ways that you can come towards a vertical asymptote? Either both branches are approaching. What happens as you come to a vertical asymptote? Good. Either both are approaching positive infinity or both are approaching negative infinity, or they disagree, right? I'm going to go ahead and do one where they're both approaching positive infinity. What basic graph has two branches approaching positive infinity? Do you remember? There's one of them. Which one? Yeah. Rachel, let's back real quick. 1 over x squared. Good. Which one doesn't have them approaching the same infinity? 1 over x. So let's assume this is a 1 over x squared that's been, shifted to the right a. So it could be 1 over x minus a squared. Just like as an idea of what this function could be. If I was to say the limit as x approaches a, here's the dilemma. According to the informal definition, paragraph. We'll get it real quick. According to the paragraph at the very beginning of section 1.2, the informal definition, the limit only exists if the f of x values are approaching a single, what's the rest of it say? Constant. A single number, a single constant. So here's the dilemma. As I come in towards A from either branch, from either side, from west or from the east, no, they're approaching an infinite, ever increasing without bound height. Well, it's not a single height, right? So technically the limit does not exist. But to show that both branches, both approaches are approaching the same idea, even though it's not a constant. I can't answer this with a constant. I can't answer it with a number. But I am, and you should still answer it with what, denoting that they are in agreement. It's just not a single constant. What can we put as the answer? Infinity. So technically the limit does not exist because that answer is not a single constant, but we still give it as an answer because both sides are in agreement. So what if the graph was 1 over x? What if the graph was 1 over x? Would the limit exist as x approaches 0, which is where the vertical asymptote is? No. Why? Not because of this one, because of that one. If they don't agree, what's true about the limit? It doesn't exist. So it has nothing to do with this one as far as agreement or disagreement. This is saying vertical asymptote technically not exist, but still look at it. If they're in agreement, give me an infinite answer. Either positive infinity going up or negative infinity going down. But if they disagree, go back to number 1. The limit does not exist. Okay? The last one. I want you guys to get out your graphing calculators. Maybe you remember this from last year, but that's okay. I want you to graph an actual function. F of x is equal to sine of, in radian mode, 1 over x. Sine of 1 over x in radian mode. I'm going to pull it up too, just real fast. And as you graph sine of 1 over x, I want you to zoom in, zoom in, zoom in, zoom in, and try to see what is the graph doing as x gets closer and closer to 0. What does the graph do as x from the east and from the west get closer and closer to 0? I'm starting in zoom standard just because you guys can start in a different zoom. It keeps sliding. It's weird. Doesn't look that weird from this view, right? Looks a little weirder, but isn't it still approaching 0? Kind of looks like it's approaching 0, right? No big deal. Zoom in a little bit more. Let's make sure. That's not what I meant to do. Now it looks like it's kind of going up and down to positive and negative infinity. I need to zoom in just a little bit more. Have you guys kept zooming? Now I don't even know what it's doing. Maybe it's going to 0? Maybe I just can't see it, so maybe I should zoom in a little bit more. Yeah, it does look like a barcode. And if you guys notice your window, right now we're at negative 0.03 and 0.03. Like, we're stinking close. Could we get closer? Yeah, we can. We totally can. It's like, okay, well, but in the table we do 0.01 and 0.001 and 0.0001 and 0.000001. I think it's just getting worse and worse. Does that make sense? Like the left and the right, literally this is 0.001, negative 0.001, that's positive 0.0. Like, we are so close to 0, and it keeps freaking out more and more and more and more and more and more. This is the case where graph oscillates between two fixed values as you approach. So it's doing a weird, and I'm just pretending because I do not have this graph memorized as far as when it's going up and when it's going down. But as you zoom in more and more and more and more and more and more and more towards 0, it just gets worse and worse and worse and worse and worse and worse. It's bouncing faster and faster and faster and faster. So this is an idea of oscillating between two fixed values. It's not approaching any value. Therefore, we would also say the limit, and in this case, it's a specific example, so I'll say as x approaches 0, does not exist. I don't put equals because, remember, equals is the word is. Equals is does not exist. That's awkward. I mean, it's true, but still kind of exist. At the very, very bottom is a note about letter B. A limit only technically exists if the answer is a single constant, a real number, but we're still going to put infinity as long as the two branches are in agreement. Okay, so then we talked about, first of all, when a limit does exist and you don't think it does with the whole. Then when a limit doesn't exist and you need to realize and remember it doesn't exist from those three cases. So let's go ahead and take all of this together. Let's write down just quick notes about one-sided limits and notation before we bust out quite the example as far as graphically finding limits. So this entire section of homework's Finding limits with tables and with graphs. You have algebraic skills, plugging in 0 over 0, keep going. I know you do. But just use those to check for right now. Just trust me, trust me, trust me. So we were talking about just a second ago the two different approaches, two different guys in cars trying to come and meet each other for breakfast. I said really quickly just a second ago that you can think about it as coming from the west and coming from the east, from the west side and the east side of a certain location. We're not saying whether it's southwest or northwest. We're not saying whether it's, sorry from you guys, southwest or northwest. We're not saying whether it's northeast or southeast, just from the west, from the east. The graph could be up or down or all over the place. Oh dear. It's even worse. Start over. So if we're coming from the west, that would be from the left of the number. And if we're coming from the left of the number, then we could say something to the effect of x is approaching a negative. The negative is in the little exponent and its number is a little bit less than, bless you, a little bit less than a. If we were to have the other type of approach, if x is approaching a with a little positive in the exponent, you're not raising anything to a power. It's just notation. X is approaching a from the left, x is approaching a from the right. You can think of it as numbers a little bit lower than a and a little bit above a. A little bit lower, a little bit above. So then if you were to see one-sided, like down here you can already see, oh, hey, they only want one of the approaches, only from one side, then only from the other side. Where's this guy headed? This specific car, this specific dude, this specific branch. Where's that specific dude, that specific branch headed? And then maybe they'll ask us to put it all together and consider both, and that's when they have to be in agreement in order for the limit to exist. But if you're just coming from one side, all you're answering is, don't even look at the other side. From that one side, what's going on? You guys should be pretty close to having that up above. I'm trying to show you the entire example. I think I need to scroll down just a little bit more, so let me give you a couple seconds to finish writing that. But as you do, wouldn't it be most helpful to have this sketch in your notes for you to go back and to study and to use and to reference? Okay, but strategize. We should at least have the graph somewhat precise in order to be able to put it in our notes and know what's going on. So what sorts of things should you guys be looking at as you're trying to sketch the graph? I would say, where are the endpoints, or at least whether or not they exist? Where are the ends? And where are the reference points in between? Because you can get the endpoints like -8, -1, and -4, and 9, and 0, 4, and 3, 3, and 6, 0, and 9, -3. If you can get those points down, whether or not they actually exist on the graph, then you can just say, oh, hey, linear increase, sweet. Concave down, y-intercept, concave up, and then linear decrease. So use those points as your reference. So in your grid, you want to make it at least a 9 by 9. You maybe don't have to go down 9. You only have to go down 4. Left 8, up 9, right 9, down 4 would be enough room. If you guys want, I'll go ahead and read off the points, if that helps. So if you have your grid, the leftmost point is going to be the point -8, 1. There's a hole. There's a hole at -8, 1. There's a hole at -4, 4. And you can connect those two with, there's a hole at -8, 1. There's a hole at -4, 4. There's a point at -4, 6. A point by himself at -4, 6. There's a hole at -4, 9. There's a hole at negative 4, 9. There's a point at 0, 4. And you can connect the last point with that with a concave down swoop. There's a point at 0, 4. And you can connect. After the point 0, 4, you're going to do a concave up swoop. If you want to put a point, you can go to 1.5 and 1.75 about. If you want to get the bottom of the swoop, 1.5 and 1.75 about. But then it ends, the concave up swoop ends at the point 33. There's a hole. There's a hole at 33, concave up swoop ends there. You're going to have a point from that 3, at 6, 0, and at 9, negative 3. You have a point at 6, 0, and at 9, negative 3, connecting the whole portion with a negative slope. Dun 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 dun. And as we went through each and every one of those points, now we should be totally ready to go ahead and answer some of these questions. I want you guys in your groups for the next, not too long, 3 minutes, to try to answer A through E. Ready, set, and go. A through E. Ready, set, and go. If you want, you can all do all 5 on your own, then grade them, check them. Or you can talk through one by one and be like, what do you guys think for A? Give everybody a few seconds and then check. Everyone try B, a few seconds, then check. I'm going to freeze the screen. All right, couple more seconds. Make sure you guys are all in agreement on A through E, or at least you've talked through the disagreement if you do have any. It's not bad to disagree, but you've at least discussed it. And here we go to check. Think through, pause, think. Don't get stuck on the fact you got it wrong. That's not bad. Think. Just from the east, then just from the west. What height? Just from the east, then just from the west. What height? with tracing. I'm starting with letter A. There's a bug. I find -4 for A. I trace and say, where's this guy headed? What height? He's headed to 4. Just from the east, just from below. This guy's headed to 4. Doesn't matter whether or not it's open or closed. That's where he's headed. That's where he's approaching. From the west of -4, this branch, where is he headed? 9. Do those two approaches agree? No. So the two-sided limit does not exist. Two-sided limit, there's no little sign up here. So it means from both sides, from both directions. They don't agree. So the limit does not exist. As I come towards 0, there's no little signs. That means both sides. As I come towards here, 0. From above and from below. From the east and from the, from the west and from the east. I said those backwards, didn't I? From the west and from the east. They're in agreement. And it's headed towards the height of 4. And it actually, breakfast is being served. They're going to be good. But they're both headed to a height of 4. And then from the left and from the right, from the west and from the east of 3, they're also in agreement. They're also in agreement. Doesn't matter, open or closed. They're also in agreement of where they're headed, and they're headed to 3. Does that kind of make sense? So there's a few places you can get confused, but just think, you're always looking for y values, always looking for the heights. These are the locations that we're answering for our limits. Where are they approaching? Look at the y's, but you have to go to the x. Figure out the two branches, the two sides that you're coming from. Figure out the two branches, the two sides you're coming from, and then ask if it's a two-sided limit, no signs, no east or west, but both. Are they in agreement? And if so, what's the height? Whether or not there's a hole or a point. What's the height? Whether or not there's a hole or a point. And then if it's asking for it individually, just look at one branch and talk about him. Just look at the other branch and talk about him. But if it's asking for both, you have to compare. If the one-sided limits agree, then the limit, the one-sided limits agree. The one-sided approaches agree. The limit exists. Good. If the limit does not exist, the one-sided limits did not agree. Good. Okay, so this is a little brutal, but it's a great practice problem with so many different pieces and so many different, this is a piecewise function with one, probably 2, and then 3 different pieces. And it didn't even go on forever and ever and ever. So, let's save that for a warm-up. Let's do this guy instead. We'll save the other guy maybe for a warm-up. You guys will get a chance to practice in homework. We've already talked about this. Let's see if you guys can go ahead and fill in the answers for the limits as x approaches c of each of the individual f of x's. And these are the last, there's technically 2 slides, but we'll go fast since we already talked about them. See if you can see it. Yeah, you can see it. Infinite limits. That happens when, as the x's come towards c, the function increases without bound or decreases without bound. As you guys are drawing, what do you guys think the answer is for letter A? Infinity. Good. As you come from the east or from the west or from the east, I should say, they're both going to positive infinity. How about letter B? Does not exist because they do not agree. One is going up without bound, one's going down without bound. How about letter C? You could think about basic graphs that match, but here's the long story short. Whenever you have a one-sided approach, could be a two-sided also, but a one-sided approach that's infinite, however, if the limit as x is either positive or infinity, it doesn't even have to be a two-sided limit, even just a one-sided limit, then there does exist It's a way of defining a vertical asymptote. In algebra 2 or algebra, you didn't see it in algebra 1. In algebra 2, is an x value that can never exist, but the function will get closer and closer and closer and closer. We'll approach it without intersecting it, without ever hitting it. But a much better way of defining it is a one-sided limit of the function as you approach this x value will be infinite. That's the end of section 1.2, kiddos. Homework due on Monday in Google Classroom by 7 a.m. Corrections do not take pictures of. It's not a picture thing. Just bring them and have them ready in class. Sound good? All right. See you guys later. Happy weekend. Almost. Hang in there. Happy Friday. Any tests or quizzes, do your best. Persevere. You're almost there. Almost get some rest. Football players,